Good morning, everyone. My name is Uddesh Soman from Ujjain Engineering College, currently in seventh semester. Uh, Welcome to the AI Club. Today, we are going to have a look at custom training of Spacy NER model. So far, what we have done with name entity recognition models in Spacy was that we use the built-in models, pre-trained models that were available in Spacy and use them for name entity recognition, for POS tagging, and all those things. Now, in this example, we will look at how to add custom entities in our Spacy model. So the pre-trained model will remain the same, but we'll be able to add custom entities into the same Spacy model. For example, here if we see, first of all, we'll need to import our Spacy model, right? So just go through that. To get a Spacy model, we'll import Spacy and we'll Spacy dot load the model. We call the dot load method and load our model. Currently, we are using the N-Core WebSM model that is available within Spacy. You will have to separately download it by the Python command. And once you have downloaded it, you can call Spacy dot load and store it into any object. So here our Spacy model will be NLP. We'll For now we'll just check the pipelines that are in our Spacy model. So we just call pipe names. So we can see the full pipeline of our model. So that is first is token to vex. So tokenizer plus vectorizer. Then tagger, POS tagging, parser for finding dependency between tags, attribute ruler for finding attribute rules and other relations between various text components, lematizer for lemmatization process, and finally named entity recognition. So these are all the steps of our Spacy model. For this demonstration, where we add extra entities into our named entity recognition model, we'll train this final part of pipeline, that is NER, name entity recognizer. So here we have a bit of text data. It is some article taken about the organizations, uh, retail organizations. So we just uh, pass the whole text into our NLP object, and the result will be we'll get this doc object. Doc object is sort of a list of all these items, list of all the words in our text, and with all those properties already found out, means all the processes of NLP is done on that text, and hence they have been classified as each and every token. So for now, we'll not see the whole text, but just the entities, the named entities that are recognized. So for that, we'll call this attribute doc.ents. This will give us entities. So we'll loop those entities, and by looping we'll print their text, whatever be the text of that entity, and the label, means whichever named entity label has been provided. So here we have India, that is GPE, means geographical positional entity. One cardinal, then again Indian is recognized as, I think it is for nationality. If we want explanation of these named entities, we can simply call that string ent dot explain labels label label underscore. By adding this simple command, we'll see the explanation of entities as well. For now, I'm skipping it because we have already seen it in our previous demo. Next up, to get, we'll have to actually extract the pipeline. So for now, we are getting the name entity recognizer. In order to get the name entity recognizer out of our Spacy model, we'll call this get pipe. So the whole named entity recognizer, that one will come into our object, and that will be NER. So this is our named entity recognizer. Next up, we have some training data. So just have a look. This is this sort of training that data that we need to provide in order to train a Spacy model. So the form of this data is sentence, whatever be the text sentence. Then we need to provide a dictionary. It is a tuple. The whole data is a tuple. See, this is a tuple with first first part is the text, whatever be the text entry that we have provided as a training data. Then the entity that is present within the sentence, that entity in the form with its index. So here it is string index actually. Earlier we have seen the doc object gives us entities, list entities, but here we are just dealing with this simple string. So string indices. So Walmart here, Walmart spans from 0 to 7. The +1 index is also included, which means if it is up to sixth index, then seventh index will be by default included as well. Then what is the label for this entity? So the label for this entity is organization, and all this is within the entity as a dictionary with entity as the key, and all these labels as a tuple within a list. So please note that, because uh, otherwise the indexing that we have done late in the later part will be will be disrupted. So our target, I'll just repeat once more. Our training data comprises of tuples. Each tuple is a training data comprising of a string, this whole string, which is our sentence or training example, and whatever be the entities that are recognized in that example. We'll call those entities. We'll just make a dictionary of entities, and we'll provide index 0 to 7, which means the starting and ending position of our entity, and what is the label of that entity. So it is organization. In case a single sentence contains multiple entities, I don't think here we have an example for that. But in case a single sentence contains multiple entities, like Walmart is a leading e-commerce company. Let me just say also Amazon. So if we are to add this, uh, if we are to recognize this entity as well, what we'll do here, if you see here, this one is a list of tuples. So here we'll add another tuple. What will that include? Amazon, the indexing of the starting and ending position of Amazon here as the indices, and the what is the label. So here Amazon is actually, we are referring to the Amazon organization. So again, we'll have to pass this organization label. In that way, we'll have to create in case there are other entities. So that's how our training data is. Next up, what we do is we have to actually add those labels into our entities, into our that.
Someone actually you have to shift to right. Yeah, now it is visible. Yeah, great.
Yeah. We'll have to add those entities into our NER, name entity recognizer. If you remember, we took out the named entity recognizer here by calling get pipe method on our Spacy object. And this NLP is actually our Spacy model object. So for underscore annotations, here we just want the annotations in training data. So what we'll get is this dictionary. By calling that comma, we'll get this dictionary will get as a result. And from this dictionary, we call because this is a dictionary, so we can call the get method and get entities. Get entities, what will do, it will return the entities key, whatever there is contained in entities key. Here we just have single part. So key contains this this list containing the tuple, and what it has, the indexes and label. So for now, we're just adding those labels into our NER model. Here we have organization, which is predefined label. Otherwise, we can add our custom labels as well in case we need to add a food, in case we need to add some other label specific, like if we are using it for recognizing the name of medicines for medical data case, then we need to add that particular entity is the name of medicine. So we'll just create a label for that. So get entities, we'll after getting these entities, we'll add label entities 2, because if you see here, it is at the second index, 0, 1, 2. So in the tuple, 0th index, first index, and second index, it is at the second index, this label. So we'll add all those labels. Now that all the labels are added to the our pipeline's name entity recognizer. So now we need to disable the name entity recognizer. Why? Because all other pipelines are all other parts of pipeline, we are not messing with them. All those remain same. We just converting the name entity recognizer. So we have to disable it. So which pipeline we want to disable? So NER, and we just get a list of remaining pipelines. So this is simple list concatenation. So pipe
Hey,
for
so
pipe,
sorry
yeah,
for interruption. So I didn't understand that in NER we added our entities. Then why
yeah.
we are disabling NER actually?
So by disabling, I mean we will train NER.
Okay, okay,
Okay, these are the remaining are unaffected pipes, means
okay,
unaffected part.
okay, okay, okay. Got it.
Yeah. So pipe any variable for pipe in NLP.pipe name. So we call NLP.pipe names, iterate all the entries in the NLP.pipe names, and if it is not in exception. So this is our list of exceptions. So only NER is there. So we'll get the list of unaffected pipes. So these are the unaffected pipes, the rest other five. And we'll train NER, the other fives are our unaffected pipes. Now we come to the main part, training. This is actually our main part. Just random for shuffling the data. And utilities we call mini batch, and compounding. Compounding actually here it was used, but compounding was used in some previous versions. So I have actually changed the code a bit. We'll not be using compounding. We'll directly call this size as an integer. Here, compounding was an object, but here we'll go with integer size. Next, from pathlib import path. Uh, that will be help that will help us to create a path. Next up,
Someone,
we
I have
have,
a question actually. Like we have added entities manually in the top. We manually added new entities, right?
yes, sir.
So then why we need to train
No,
the model?
sir, we let me get it straight. We have not included entities. We have included the label,
Okay, so we have included new labels. So then why we need to train our model for new labels?
because our model doesn't know that that label correspond to that entity, because it knows that organization is label that we have added, that org label. In case we might have other label such as food or medicine, we'll need to add those labels as well. But the thing is, up till this part, the model does not know that Swiggy is a organization. It does not know Flipkart is an organization. For that, we'll have to train the model.
Okay, okay, okay. Good. Thank you. It is good.
So, and also we'll need this Spacy training example, because there is something called an example object, and that example object will be needed to train the NLP or Spacy model to add more labels and more entities as an example. So we will need this example object. So we train the model. So with disable pipes. So everything that is not in the unaffected pipes, whatever is not in the whatever is in the unaffected pipes. The star is for all. So whatever is in unaffected pipes, we disable them. So disable them for the training purpose. Whichever remains, whichever is enabled will get trained. That's why others are disabled. For iterations in range 30, right now we'll just run 30 iterations. We'll shuffle the training data to create randomization. We'll shuffle the training data. There is a dictionary for losses. Next up, yeah, here is the main training loops. So for batch in Spacy.utilities mini batch. Mini batch will need a mini batch object for training data. So it creates small batches of our training data. So whatever the size that we specify, that size ends up in a single batch. So here we have
Where we have given the size to Soman? Batch size?
here, no sir, just coming.
Oh, size equal to only two.
Yeah, we only have a few samples now. Just this much
Okay,
sample, so
okay,
two
okay,
won't make you problem.
okay.
So size equal to 2. For text annotations in batch. So text will give us our string. Text will give us our string, and annotation will give us this dictionary. So for text and annotation in batch, we'll make a doc object out of text as we have done earlier. But this time we'll use the NLP.makeDoc for the training purpose. We'll pass text into NLP.makeDoc text. We'll get the doc object, the one we have seen so far. Now we'll create an example object out of it. So if you here we have imported this example object that is available in Spacy model. We'll create an example object out of it. So our doc object and annotation. From annotation, it will automatically extract this thing, that labels and their position and the position of entity, that it will see from the doc object, and we call this NLP update. By using NLP update, it will update our model, add all those labels into our NLP model and train it. So instead of as we have seen, there was fit in our sklearn models or keras models, there was fit method. Here it is the NL update method. We update it, we get the example object that we have created earlier. We pass our example object into it. There is a dropout rate for regularization and losses. Dropout rate actually is one of the internal processes. It is actually quite different from keras, but I wasn't able to find the documentation on this. So just for the sake of now, this one is just simple regularization, whatever is the top, and losses.
Actually, Soman, I am not getting why this object has been named as example. So is it a real example or it is just named as example?
It is just named as example, sir. There is a class for and making training data in Spacy, that is example class. So we actually whatever the object that is created is object belongs to this class. Whatever the because we this is the way Spacy was designed. Na? Otherwise, in our Keras, it was simple that we take a couple of columns and just a target and we train from that. But here, because we have text sentence with entities and then at certain position those entities are present. So for that training, I guess they have separately made this class for specific
Yeah,
training
and
purpose.
I also looks like that for training we have to supply our training data in the form of doc comma annotations. So that is a
Yeah,
specific format in which we
yeah.
have to supply the data to training for dot NLP dot
I
update.
yeah, I guess
Yeah, so
that's how
yeah,
the developer made the library. So I
yeah,
don't
yeah,
think there is an exception
correct,
for this.
correct.
So here we once we have created our example object from doc, that is our text passed through NLP model and annotations, whatever the annotations that we have. Then uh, just a print statement for losses. We don't actually need it for training. We just to visualize the losses. Here the whatever losses there are, they are stored in this dictionary that we have provided for each training purpose. So this runs for so this step will run for two batches. Oh, sorry, two samples, and this whole process will run for 30 iterations. So now that we have here are some losses that have been visualized. So if you see, losses are actually quite variable over the whole training. Yeah. Next up, once we have trained our model, now we'll check for some custom entities. So doc NLP, I was driving in Alto, so we haven't gone with the product entity, but just for checking it. So we check the entity text and entity label. So here we have Alto, which was recognized as a product. Next up, we have another example. I recently ordered from Swiggy. So Swiggy was in our training set. We have trained our model to recognize that Swiggy is an organization. So it works. We call print entities and enter text. So this Swiggy is now recognized as an organization. So that's how we can train our model and add custom entities in it. There was also, if you want a whole new model for a particular purpose, having particular entities, then we also have the option to use a blank model. There is something known as blank model that is available, but will not cover that. We'll just go with this update model part. So yeah, that was all for today from my side. If
Nice,
anyone have any
yeah.
questions, please.
Yeah, nice, Soman. Thank you so much.
Thank you,
So it
sir.
was pretty straightforward, and I think almost everyone understood it. So I think this was pretty simple use case of we training a Spacy model for new entities and new, like introducing new objects as new entities, like Swiggy was introduced as organization. Then we introduced a new product as products. So that's what we did here in this training. And thanks for explaining this very intuitive and straightforward use case. So what my question to you is, like, Soman, are you aware of any complications which are have you seen? Are you aware of any complications or any twisting, like twists? इसको बोलते हैं ना, what is twists?
Mm.
So any twists? Are you aware about these variations in this problem or in this use case, which may complicate the coding? Are you aware of those cases? If right now not, then we can see it in one of the next training sessions. So its question is
Yeah,
optional to be answered right now. It's not compulsory for you to answer this question right now. We can look at it later as well. But if you are aware,
No,
you can tell if there are any twists available in this particular use case, so which complicates the coding actually.
uh, first of all, I'll say the complication was mostly with how we treat the training data because Spacy is a different library and all the coding that we need to do to train the model is actually different from what we have seen so far in all the common machine learning libraries like sklearn and TensorFlow Keras. So that was one part. Otherwise, most this part of code was mostly simple. There was not much complication. You have to, however, just keep in mind while this, yeah, disabling process, which pipelines to disable, and you have to keep in mind which list are you passing while disabling your pipelines while training purpose. That is one thing we have to keep in mind. Otherwise, the code was mostly straightforward, nothing much complicated. We'll just have to, in case we face any errors, that is better to go with Stack Overflow because sometimes the modules are updated and the latest versions are not compatible with uh, earlier format of code. We have to update our code accordingly.
Yes.
And
Thanks, Soman.
one more problem I faced was actually I also included that part where we train a blank model to recognize custom entities, fully custom entities, but that unfortunately didn't work. It was not performing so well, so that was deprecated for this part of demo. But yeah, if in case we get a working demo ready, then we'll add in future.